Okay, we're going to talk now a little about how to solve some of these word problems dealing with growth exponentially. So first off, let's practice finding b. That's our growth or decay factor in word problems. Often you're given a rate of increase or decrease, and all you got to do basically is just take that rate and add it to 1. Why is this? Is because 1 kind of represents your base. You're starting from 1 or 100%, and then you're either going to increase if it's a positive or you're going to decrease negative. So for example, let's say we want to find b given the rate of change annually. So 70%. Let's say something's increasing 70%, which is quite a bit. So our b, we would just take b, and well, first we want to change 70% to a decimal. So I would just 70% is 70 out of 100. And since I'm dividing by 100, remember you just move the decimal twice. So that equals 0.7. You don't need the 0 afterwards. So we're going to use that decimal representation. So b equals 1. Now, since we are appreciating, it's adding 70%, we're going to do 1 plus 0.7. So our b would therefore be 1.7. And we can see that this is exponential growth. It's bigger than 1. Let's do another one. b equals plus, I don't know, 490%. So a huge increase. Some kind of huge increase. So again, to find the decimal representation, you divide by 100. So move it over twice. So that's 4.9. 4.9. So basically to find b, you start with 1. That represents kind of your base of 100% where you're starting from, and you're going to add 4.9 since it's going up. 1 plus 4.9. So our growth factor would be 5.9. And again, it's obviously growth bigger than 1. Let's say we have something where it's going to go down. Let's say something is decreasing by, I don't know, 7% instead of 70%. So this time, our decimal is going to be, we move it twice. So we're going to get a negative 0.07, right? Move it twice to fill in the 0 right there. Okay, so our b would therefore, again, be 1 plus a negative 0.07. So basically you have 1, I think of this in terms of money, you have like $1 minus 7 cents. So you're going to be left with 0.93. 0.93. And since that's less than 1, this is a decay factor. This is decay. All the other ones obviously were growth. All right, let's try another one here. What about something really small, like something is decreasing negative 0.1%. So not 0.1, 0.1%. So again, that's the same as saying negative 0.1 out of 100, which would mean you move it twice, the decimal to the left. 1, 2. That means you're going to have 2 zeros to the left. 1, 2, like that. Right, you move it twice. 1, 2. So our b equals 1. I'll start with 1 plus a minus. In other words, just minus 0.001. So not that small of a decrease. And here we're going to get, so we start with 1, so we're going to get 0.999, right? Because 999 plus 001 equals 1. So there we have it, calculating some b's. We're going to need that to do our word problems. So yeah, let's work on a few word problems. I've got this thing up here. For each problem, we want to write a function that models the situation. We'll find the value after 3 years and 10 years. So first off, let's start with a house bought for $300,000, appreciating by 3.2%. So it's an exponential function. Start with y equals a times b to the x. Now let's remember, our a always equals our initial value, right? Our initial value of y at, again, x equals 0. And b, again, is our growth or decay factor. Growth or decay, and we already practiced finding that. So the first one, the initial value is pretty simple. It's bought for $300,000, so y equals $300,000. Now we need to figure out, is it growth or decay? Let's see, appreciates. Appreciates means it's going to go up. So we'll call that our r. Our r is 3.2%. It's increasing. So again, we're going to calculate that as a decimal. So move it over twice, 1, 2, so 0.032. Okay. So we're going to take, to find b, we start with b equals, always start with a 1, and since it's appreciating, we're going to add 3.2%, we're going to add 0.032. If it was depreciating, if it's going down, obviously we would subtract it. We get 1.032. So we still have some exponential growth going on here. Let's put that in here, 1.032 to the x. So that's our function. Let's go ahead and calculate that when x equals 3. So 3 years later, again, remember you do this one first, order of operations. So 1.032 to the third power times $300,000. There we go. So approximately $329,000. Call this letter B, I guess. So the first one is approximately $329,000, $731.43. And if we use a 10 instead, so 1.032 to the 10th power, 1.032 to the 10th power, then multiply that by 300,000, we get $411,000, approximately $411,000 and 72 cents. Sorry, $411,000, $411,072.31. Having trouble talking today. Okay, the second one, number 2. Let's say you've got a car bought for $15,000. So again, that's your initial value. So y equals $15,000. And it is depreciating by 14.3%. So we need to figure out what this is. Our B. What is our B? So first off, our rate of increase or decrease, it is depreciating. Depreciating means to go down, so it's a minus 14.3%. 14.3%. So again, to convert that to a decimal, move it over twice. So here we go. We have negative 0.143. So our R is that. That means to find B. B equals 1. And since, again, we start with 1, we're depreciating. We go down 143. All right, so we have 1 minus 143. I kind of think of this maybe as like 1,000 minus 143. So that would be, let's see, 900, 860, 857. We can check that by adding it again. So 8 plus 1 is 9.9, 0.99, and then you got 1. All right, so that's our B. It's depreciating, so it's going down, 0.857. All right, so we've got our function. Let's go ahead and calculate it after 3 years. So x equals 3, and then 10 years, x equals 10. So 0.857 to the third power. Okay, I'm going to multiply that by $15,000. So that's $9,441. So part B, $9,441.34. And we'll do the same thing after 10 years. No, x equals 10. So 0.857 to the 10th power times 15,000 equals 3,205. 3,205 and 53 cents approximately. Okay.